That's how I do it.
I went to her little tutoring after school like every day.
Every morning I come in and just pull out this stack of papers that I needed to finish.
I think you're going to get it this time because you've already done it all last year.
Maybe
You got you're
better than she does.
older, or you're a year older, and I think. Okay.
Sure.
All right.
Sort of.
Okay, this first part though is transformations and like midpoint, like this one. Points K and L are shown on the grid below. If point K is the midpoint of JL, what are the coordinates of endpoint J? So where does J need to go? Below?
Up 4.
Okay, up here somewhere?
Yep.
Okay, and what did you say?
Up 4.
Okay, so you just count up from L, 1, 2, 3, 4, and over to K, 1, 2, 3, 4. So from K, we go 1, 2, 3, 4, and over 1, 2, 3, 4. And label that J. What point is that?
Negative 6.
Negative 6, 7.
Yes, what did she say?
She said exit geometry would be fine. So we have maybe.
Yes. We want to just do this right here.
I didn't mean to.
You do. I don't know.
Get angry over
Do we want to go over it with, this is a teacher led, where you go over it with them, and then they do this. And there's two parts, and there's another teacher led and another one.
Okay.
Okay.
What's our tax?
3 weeks, we have 3 weeks and then tax. Yeah, it's
We have
coming
like
up,
40
coming
days.
up. I
of
was thinking we
school.
had 4, I was wrong. Oh, I
We
got
have
it
like
wrong.
40 days of school.
Okay. Yeah.
It's so ridiculous. This year has gone by.
It's gone by so fast, I know it. Okay, now triangle RNV is shown on the grid below. If triangle RNV is reflected across the line y equals x, which we had done a lot of, remember y equals x?
Oh, that line
The
there.
diagonal one.
Okay, let's draw that on there.
It goes through the origin.
Yes. What else do you know about, when did we study that? Where we reflected it across
It's the
the
inverse.
Inverse,
And
very
you
good.
Switch the x and the line coordinates.
Way to go, Smith. Okay.
Okay.
One thing about inverse is it's reflected across y equals x. The other thing we know about inverse is you switch x and y. Y'all remember that? Kind of? All right. You can reflect it. It's just hard to reflect, but you can. Nothing. Okay. Like if you look at, it says, all right, it's reflected across the line y equals x to become triangle R prime, M prime, V prime. The prime ones are always the new triangle or the new figure. The ones without the primes is the original figure. Okay. What would be the coordinates of V prime?
Just move it over a little bit.
You can, the way you do reflections though across y equals x is you go down to the line, wherever it is, and then over 1, and it would be right here. Or if you can remember to switch x and y, that's the easiest way to do it. What are the coordinates of v?
There's 7, negative 7, negative 6.
Okay,
So it would be negative 6, negative 6.
right, we would switch x and y for v prime and get negative 6, negative 7. That's the easiest way to do it. Like r, let's look at r just for a second. Getting it to here, you would go over 1, down 1 like that.
It would be negative 2.
So r would be over here, Or you could just switch negative 4, negative 2 to negative 2, negative 4. Okay? Right. Okay, now number 3, I did this last year. This is when you dilate something. What does it mean to dilate it?
Make it bigger.
Make it larger or smaller.
Or smaller. Okay? Makes it larger or smaller. And this has the center of dilation at the origin. Okay, that's why they draw these little dotted lines that connect the figures together that go through the origin.
That looks pretty cool.
Okay. All right, so your original figure is PNTW. Should be an N over here. I don't know why it's not there. PNTW. Your new figure is P prime. So where's P prime?
Below.
Okay, P prime, N prime, T prime, W prime. I'll have to get it to you in a little while, Brian, okay?
Okay.
Okay. Which scale factor was used to create P prime, N prime, T prime, W prime? Now, is P prime larger? Is this figure larger or smaller than the original figure?
Smaller.
Smaller. So A scale factor is what you multiply by. It's a
So
multiplier.
it needs to be less than 1.
Right, you're going to multiply by a small number, right, so that it would get a small figure. Right, so if we're looking at what we think it might be, it wouldn't be probably C or D. Probably A or B, but we're going to check it. How can you decide
Can
which
you
one?
take the coordinates and multiply by that one of those numbers?
Yes, you can. Let's see, what's the coordinates of P?
P 6, 4.
No, not P prime, but P.
9, 6,
Okay, and the coordinates of P prime.
6, 4.
Okay, then you want to know what would you multiply the original by to get the new one. You always do multiply the original to get the new one.
2/3.
Okay, let's try 2/3 and see if that's it. 9 times parentheses 2 divided by 3, and you get 6, don't you? How about 6 times 2/3? You get 4.
That's it.
Yep. Let's check W just to be sure. What are the coordinates of W?
15, 12,
And the coordinates of W prime.
10, 8.
So multiply, what would we multiply by?
2 divided by 3.
Okay, so 15 times 2 divided by 3? Always your original? And you get 10. And 12 times 2/3? We get 8. Okay, so it's 2/3. Now, if you were going from the new one to the original one, what would it be?
You just
3/2.
3/2. That's right. You would flip it.
So you just take the original and multiply
See what you multiply by to get the
to
new
get the
one.
new one.
Right.
And you will never divide in that situation, will you?
Okay, I mean, yes, you can divide, but
It's easy.
don't go by, yeah, don't think about that. Just say, what am I gonna multiply?
To get the new one.
Yes. Because that's what a scale factor is. It's what you multiply by. Okay, for which point is x less than negative 15 halves and y less than negative 3 halves? Any ideas?
I say
We make those like
That would
real
be
numbers.
like
M.
So what is negative 15 halves?
7.5.
Negative 7.5?
Yeah.
Okay, and y is less than?
-1.
Okay, so we're looking for a point that has the coordinate x less than negative
Don't you
7.5.
shade?
You can shade, or you can just compare coordinates. What coordinate did you think it was?
M.
Okay, what are the coordinates of n?
8.
Negative 8. Negative 8, negative what?
7.
No.
Wait.
3.
Oh, you're saying
I'm
m.
saying M.
I'm sorry. 8, negative 7? Okay, let's look at m. Is 8 less than negative 7.5?
No.
It's not.
Yeah.
8 is
Oh,
n.
negative. I was doing negative.
It needs to be in.
So it's not that one. So try n, negative 3 here. Is negative 8 less than negative 7.5?
Yes.
Yes. Is negative 3 less than negative 1.5?
Yes.
Yes. Okay, or you can shade. Now, how would you shade, Wyatt?
I have no idea.
Just shade.
You go to
That way.
negative 7.5
On the
Shade
on the
the
x-axis.
on the x,
And you shave
the bottom.
To the left of
to
it.
the left of it.
okay?
Then you go to negative 1.5 on the y, and you just shade this,
Since it's less than, you shade
let's shade under it.
under it. Good. And then where they intersect is right here. So the point has to be in that shaded region. Okay, that's another way to do it.
Oh, I hate similar triangles.
What does similar mean?
They're
Related.
pretty much like they're the same except one
Like-
dilated.
Yeah,
Okay.
Scale factor.
All right, so they have the same shape, different size. The shape doesn't change, it just gets bigger or smaller for similar. Okay, so if the shape doesn't change, then what do you know about these angles? Like, they stay the same, don't they? Okay. So it says which statement is true, circle true. When you have a text thing, circle true, false, not, those kinds of things, okay? when transforming triangle XYZ to the prime. So we're going from the original to the new one. Okay, so is the original one smaller or bigger?
Smaller.
Smaller. So we're going to need to multiply by a
Bigger number.
a number bigger than 1 to get the bigger triangle.
So it'd be 8.
Okay, so we can eliminate G and J because they aren't bigger, are they?
And then you can eliminate F because it's angles.
Because the angles don't change. Okay, because the shape stays the same. So it's now, how can we make sure it's 3?
Get a point and multiply by 3.
Now you can't do the points because
I
Read.
counted the bottom.
yeah, the reason we can't do the points is different than this one. This one, there was the center of dilation was at 0. It's not like that. Okay, you have to do the see if the sides are multiplied by 3.
So you count how many units are inside.
So there's 1, 2, 3, 4, 5, 6 in this one, and we use this one because it's easy to count. And then there's happens to be 18 in the other one. So is that 3 times as big?
Yes, ma'am.
Yes.
Wait, why is it no N?
Because the angles don't increase; they stay the same. Like this angle with X, it's the same angle at X prime. They're the same size. Okay, number 6 is one of the hardest problems on a TAKS test. It's not real hard. It can be really time consuming, but let's look at this. The area of this regular polygon is 72 square inches. What does regular mean?
And all sides are the same.
All sides are the same. Like, so if you have a regular hexagon, all 6 sides are the same. This is a triangle. How do you find the area of a triangle?
Base times height divided by 2
And if you forget, where is this?
on the formula chart.
On the formula chart. Okay. Right, where's the base?
Who's the bottom?
At the bottom. This is your base. Okay, where's your height?
The middle.
Good, up in the middle. Perpendicular
That's
distance, yeah. Okay. So find the approximate length of one side of this polygon. I haven't given us anything. No sides of anything. Any
Gives
idea?
you the
You can
area.
know that this one is a right angle.
Yes, right here, down here. Yeah.
Gives you
It's
the
gonna be
area.
a 30, 60, 90.
Or 30, 60,
It can be a 30, 60, 90, but we still don't have any
Gives you the area.
sides. We gotta have at least one
Can I
side.
just plug in each one?
Yes, that's the only way to do this one, really, is to take A and plug it in. So it says, find the approximate length of one side, so we could say, well, let's see if this side is 12.9. And then we'll see if that side is 12.9, do we get an area of 72? So we gotta
Would
find,
the height be 12.9?
no, we have to find the height.
So you cut the 12.9 in half. and
Okay.
use the Pythagorean
And
theorem.
then, yeah.
Very good. 12.9 divided by 2,
6.45.
6.45. That would be this, just this half, right?
Yes.
Square.
So we have a right triangle, like Callie said, and then white, so we can use Pythagorean theorem. So what's Pythagorean theorem?
A squared plus b squared equals c squared.
Okay. So what would we plug in for that?
6.
12.9, the square root of 12.9 squared minus 6.45
Okay.
squared.
Or 6.45 squared plus b squared equals 12.9 squared. You were ahead of us. Okay. So then you're going to subtract the 6.45 squared from the 12.9 squared, right? Okay.
124 centimeters and 5. And then square root
Square root it.
11.17.
Okay. You know how to square root it. Everybody knows how to square root it, right? So-
Square root?
Yeah.
Or square?
Yeah, second squared, right. Okay, so how does that help us?
Now we can find the area of the
Multiply it
base.
by 12.9 and then
We've got the height, right, and we have the base, so we can find the area. So the area equals 12.9 times 11.7 divided by 2. Base times height divided by 2.
That gives you 75.
Yeah,
We're close.
so that's not it.
Whoops, wait a minute, it doesn't give you 75.
I got 7.
I got 75.46.
You got 75.46.
I got 72. How are y'all getting
Because
75?
we didn't do parentheses.
It doesn't matter.
No, I did 12.9 times 11.7.
I put 11.
Oh, it's not 11.7. I'm sorry, I put that up there wrong. It's 11.17.
What are the odds the first one?
So sorry. I know, it is. You do
So-
get 72.
Ms. Walton,
So the A is right.
okay, so if if A wasn't right,
Mm-hmm,
do you have to find the base again?
mm-hmm. You'd have
and
to
the
start
height
over
of
again.
With each one?
Yes, this is a long problem. This might be a problem that you would save for the end. We'll come back to. Okay. Yeah, your goal is to get commended in here. So I think you can miss anywhere from 6 to 8. I need to find out exactly how many it is you can miss to get commended. But so this, might be one that didn't work out for you. But you've got a few to work with. So. Okay, at what coordinate should vertex Z be placed to create quadrilateral WXYZ that is similar to quadrilateral PQRS? What's a quadrilateral?
4 equals seven.
Or not equal, just
Just
four
four
sides. Yeah, they don't have to be equal. A regular quadrilateral would be equal. Okay. Similar means they have the same shape but different size. Now, let's look, if you start at the origin and point Q goes with point X, y'all remember that?
Yeah, I just found the factor.
Okay, but you got to know that you can do that. See how you can draw a line from the origin straight through those points? And then look at P and W. You can draw a line from the origin straight through those points. And R and W. Okay, so this is one of those where the center of dilation is at the origin. So that means that you can take the coordinates and use those to see that this point Z out here. Okay, so we need to find out what we're multiplying the little one by to get the big one, don't we?
4.
How'd you get that?
Q's points and X points.
Okay, what's the
2, 2, and it changes to 8.
X is 8, 8, so you're multiplying by 4. So we need point S.
6, 6, and 4.
So you multiply that by 4 to get Z.
24 and 16.
I would use R and Y and it was
Same thing. Either way. R and Y does the same thing. I like 2288, but. Okay, everybody okay with that one? All right. You've already done the hard one. These are easy compared to that. Okay, triangle WXY is a right triangle, and they show us where the right triangle is. And then they give us what XW is, but they want us to find the length of WY. Can we use Pythagorean theorem? Why not?
Because you need another
We
side.
need another side, and we don't have it. So, any ideas?
We're going to use that X squared thing.
Yeah, the 30, 60, 90. Everybody get your formula chart out. It's really not bad. It really is.
I just
Okay.
forget which side to put on.
I know, we're going to learn this, okay? I'm going to show you what to do. But you have to have your formula chart. It helps a lot to have the formula chart.
Isn't
The opposite.
hypotenuse 2x?
Okay, yeah, let's just look at here. It has 30, 60, 90. These go in order. So the X goes with the smallest angle. The X squared root 3 goes with the 60. The 2X goes with the 90.
Is that
Okay, now that means that the X is across from the
40,
30.
right.
Okay, and here's the 30. And basically the smallest angle goes with the smallest side. Okay. The largest angle goes with the longest side. The middle angle goes with the middle side. Okay, so the 60, across from the 60 would be what?
3 is X is squared root of 3.
X square root of 3. I'm going to circle these. What's across from the 30?
X.
X.
And then what's across from the 90?
2X.
Okay, now they give you the length of one side. So whatever length they give you, you set it equal to whatever you wrote down for
So
that
it'd be like
side.
40X, right?
No,
Just 40.
40 equals X. That's our X equals 40. Okay? Right, and then you can plug 40 in for X in the other one.
So you get 40 square root of 3.
Right,
And
so we just plug that in here. So WY equals 40 square root of 3, which is D. Okay. But let's talk about something. What if 40 had been the length of WY? Say this had been 40.
Then you find out. You plug in,
What do you do? What do you write here?
don't you plug in 40 to the square root of 3?
Mm-mm. No. You're saying that this side equals x squared root of 3 and it equals 40.
Square
You
root
make
of
them
three.
equal.
So x squared root of 3 equals 40. You make them equal to each other. Okay? Every time. Make them equal to each other.
And then when you square,
You have to get
Divide.
x by itself. So we divide by the square root of 3. And whatever that is. Okay, that would be like 23.09, or we can put 23.1. Okay? That would be what x is, and then you would plug x in here and here to get the other sides.
okay.
Okay. Okay, so if you label your sides, and to whatever side they give you, make them equal.
I didn't even know it was on the formula chart.
Really?
Yeah.
Okay. I always just use the formula chart because
Well, that makes
you
it a
have
lot
it.
easier. Because
Okay.
you know where to put it.
Now, the other thing that's neat about 30, 60, 90, and this you may be able to remember, is that the hypotenuse is always twice as big as the short side. So if they had said WX is 40, tell what's the hypotenuse, you would just multiply by 2, 80. Okay. The hypotenuse, the long side is always twice as big as the short side. Okay, number 9, isosceles triangle. What does that mean,
All
isosceles?
sides are equal.
Nope.
No, two are equal.
Two are equal. What's the all side equal? What is that called?
Equilateral.
Yes, equilateral.
Scalings are all different.
Scaling's all different. Very good. So if the two sides are equal, what else is equal?
The angles.
The two bottom angles are equal here, the base angles. Okay. It says the interior angle W measures 100. The measures of all three interior angles of triangle WXYR. Now we know all three have to add up to what?
180.
180. So what about F?
Nope.
Too big, right? They all add up to 360. How about G?
No.
They all add up to 300.
No, because this is different.
Okay, now H adds up to 180, but we don't have two angles the same. So J, does that add up to 180?
Yep.
And both angles are the same? So that's it.